Welcome back. In this section, we'll be looking at application of antiderivatives and so of indefinite integrals as well. So if you remember from Cal 1, the cost function c of x gives the cost of producing x items of a particular product. The marginal cost is the derivative c prime of x of the cost function. So you have the cost function c of x, you have the derivative c prime of x. The marginal cost, this derivative, gives an approximation for the cost of producing one more item. All right, so let's do example 3.1.8. Assume that the marginal cost of building a giget is c prime of x, which is 2 over 4 plus x squared plus 6x to the 5. Find the cost, c of x, of producing x unit if 2 units cost $64 to make. So this is a bit backwards from what you've seen in Cal 1. In Cal 1, we would give you the cost function and ask you to find the marginal cost. Now that we have antiderivatives and integrals, we could do the opposite. We can give you the marginal cost and you can find the cost function. Okay. All right, so c of x is the only antiderivative of c prime of x for which, so the one thing that will make the actual antiderivative specific is the fact that we know the value at one point. So for which c of 2, if I build 2 units, that's 64. All right, so let's find all antiderivatives, and then we'll see which one is the right one. So I'm going to take the integral of this function. That's going to give me an expression that represents every single antiderivative. So that's 2, 4 plus x squared plus 6x5 dx. I need to integrate this. I'm going to get 2, the integral of 1 over 4 plus x squared dx, plus 6, the integral of x5 dx. Now I know how to integrate these two functions. This is an arctan with a squared is 4, so a is 2. So I'm going to get 2 times 1/2 arctan of x on 2 plus 6 times, this one is a power rule, so I get x5 plus 1 over pi plus 1. So that's x to the 6 over 6. And then I put a plus c. All right, so let's simplify this. The constants simplify nicely. I get arctan of x on 2 plus x6. All right, so this expression represents every single antiderivative. I'm looking for one specific one, so I need to figure out which value of c would fit my extra condition that c of 2 is 64. All right, so I get that c of x is equal to arctan of x on 2 plus x to the 6 plus c for some number c. And so if I look at 64, which is c of 2, that's arctan of 2 on 2, arctan of 1, plus 2 to the 6 plus c. All right, let's see. This is arctan of 1. Arctan of 1, if you look at your table, that's pi on 4. It's 45 degrees. Slope is 1, angle is 45. So I get pi on 4. 2 to the 6, 2, 4, 8, 16, 32, 64 plus c. And so c equals minus pi. Well, actually, let me put the whole formula. 64 minus pi on 4 minus 64, so I get minus pi on 4. So my cost function is arctan of x on 2 plus x6 minus pi on 4. All right, so this is quite typical. If I know the derivative of a function and I need to find that function again, I'm going to have a special condition here, and what we call usually an initial condition. That's going to allow you to figure out, of all the possible antiderivative, which one works in my situation. It's going to allow you to solve for c, and once you have c, you have your function c of x completely determined.